So now this video discusses about the intervals, and I will have the understanding of the number lines, the types of intervals, and also how we can present the number on the number line, and some sort of the inequality symbols. So keep that in mind. Let's say we have the number line. Let's say this is a typical number line. And you should have to understand that the number line is the horizontal axis that represents the all real numbers. And basically starting from 0, that is the origin, and the numbers towards the right hand side of 0, they are positive numbers, of which you can have, let's say, 0, you can have 1, you can have 2, you can have 3, like that. And until we reaches at the positive infinity, since the numbers has no end. And the numbers to the left hand side of a 0, they are negative numbers, in the such that you can have, let's say, -1, -2, -3, and the negative infinity. So this is how you should have to understand about the components of the number line. It consists of the origin, which is the center, and which is more associated with 0, and it consists with the negative numbers as well as the positive numbers, and of which basically the positive numbers are to the right hand side of a 0, and likewise the negatives are to the left hand side of a 0. So bear that in mind. So let us see how we can express the relationships that exist among the numbers on the number line. You should have to understand that from 0 to the right hand side of a 0, the numbers are positives and they keep on increasing. So from 0 towards the positive infinity, the numbers increases. So increasing numbers. So the numbers are increasing. Likewise from 0 to negative infinity, the numbers keeps on decreasing. So here are the relationships that you have to understand about the numbers, on the number line, if that is the case. You should have to understand that 0 is less than 1, because as we move towards this direction, we are increasing the numbers. Hence 0 is less than 1, which is true. And I can also say 1 is less than 2, which is true. And likewise, you can also say 2 is greater than 1, which is true. And I can also say, let's say, -2 is less than 0, which is true. And let's say -3 is less than, let's say, 1, which is true. So that's how you have to understand about the relationships that exist among or between the numbers on the number line. And these relationships can be expressed using what we call it as the inequality symbols. So what are these inequality symbols? We have the first symbol, which is greater than. So greater than. And basically it is symbolized as, that symbol. That is the symbol for greater than. And we have the another actually inequality symbol, which is less than. And the sign associated with less than, it is given as this. And we also have what we call it as the less than or equal to. Less than or equal to. Less than or equal to. And the sign associated with less than or equal to, it is given as less than and the horizontal bar down. So that is less than or equal to. And we also have what we call it as the greater than or equal to. We have what we call it as the greater than or equal to. It should be that. Greater than or equal to. And the sign associated with, greater than or equal to, it is given as that one. So those are the inequality symbols that are used to express the relationships that exist among the numbers on the number line. And for the sake of interest, we can say -3 is less than, let's say, 0, which is true because -3 is smaller compared to 0. And we can also say, let's say, a 3 is less than, let's say, should be 5, which is true because 3 is a smaller value than 5. And what if we have, let's say, -1 is greater than, let's say, 2? Is this true? No, because -1 is a smaller value than 2. So this ain't true. But let's say if we have -3, let's say greater than, and that should be about, let's say, -4. This is true because as we go in this direction, the numbers keeps on decreasing. So if which -3 is greater than -4. So keep that in mind. And we can also have, let's say, let's say 2 is less than or equal to -3, and which is true as well. Should be is greater than or equal to -3. Know that one. That should be greater than or equal to -3. That is. And I can also have, let's say, -2 greater than or equal to, let's say, -5, which is true. So that's how we can use the actual inequality symbols to express the relationships that exist among the numbers on the number line. And now let's understand about the intervals. What are the intervals? If we say an interval, that is the correction of the numbers. It is the set of the correction of objects, or I should say it is the set of the correction of numbers. That is what we call as the interval. And for the sake of interest, let's say if we have the numbers given as, let's say, 2, 4, 5, let's say 6, 7, 8, let's say 9, up to 10. And we can think of having, let's say, several intervals on these numbers. We can have the first interval, which is, let's say, 2 to, actually, let's say, which is 2 to 5. It means this interval consists of the numbers from 2 to 5. And I can have the interval 5, let's say, to 8. It means this interval consists all numbers from 5 to 8. You can have, let's say, the interval 8, let's say, to 9, let's say 8 to 10. It means this particular interval consists the numbers from 8 to 10. You can have that. And let's say we have the interval we can develop from here. Let's say 2, let's say to 7. It means this interval consists of all the numbers from 2 to 7. And we can have, let's say, another interval. We can say it as, let's say, 5 to 10. That is, it means this interval consists of all numbers from 5 to 10. So keep that in mind. And we have two types of intervals you should have to understand. We have what we call as the actually bounded interval. Bounded interval, and we have unbounded interval. That is. So bounded interval, these are the intervals with the ends. They consist of the lower value as well as the upper value. Those are the actually bounded intervals. They start from somewhere and ending somewhere with with a definite number. We can start from, let's say, 2 to 5. This is the bounded interval, since it starts from 2 and ends at 5. And how about unbounded intervals? These are the intervals, that start somewhere and the ends at infinity. You can have, let's say, the interval, let's say, 2 to, let's say, positive infinity. This is an example of the unbounded interval. Interval with no ends. It starts from 2, but it ends somewhere which is undefined, actually, which is you cannot express much about, because interval actually because the infinity has no end. So this is a typical example of the actually unbounded intervals. And let's scrutinize much about these intervals for the sake of interest and for you to understand much what actually their working principles and their basic. And for this case, let's have an interest to have several intervals using this number line. We can have the set of the numbers from -3 to let's say 0, and this is the interval. And let's say we can have, let's say, 1 to 2. This is an interval for interest. And let's say we can have 0 to 5. This is the interval for interest. That is okay. It means the interval starts from -3 and to 0. And the interval starts from 1 to 2, and the interval starts from 0 to 5. That is okay with us. But now the presentation of the intervals has to depend on one or two things. You should have to understand. The intervals has to be presented using the brackets. And what are these brackets? We have what we call as the open bracket. We have what we call as the open bracket. In the open bracket, and basically is as simplest as this. Open brackets, that is. So this is how the open brackets looks like. Using these brackets, it means, these brackets shows that with the given intervals, the end values are not part of the intervals. That is about the open intervals. And for example, if we have the interval given as 2 to 5, as you can see, these are the open brackets. And as it stands, that means 2 and 5 are not part of the interval. But the values but the values between these are the ones that are part of the intervals. The likes of whichever the values that are between the two numbers. So it means in this case 2 and 5 are not part of the interval. That is about the open bracket. And we have what we call as the cross bracket. So cross brackets, they are simplest as should be like this. And we call also them as the square brackets. These brackets shows that the end values are part of the interval. Let's say if we can have, let's say, 2 to 5 in this case. So what it means is that 2 and 5 are a part of the interval, as you can see there. So keep that in mind. And let's see how we can express the the intervals in the brackets and specify the meanings as well. Let's say if we have open bracket -3 to 0. This is a typical example of the bounded interval because it starts from somewhere and ends somewhere, which is from -3 to 0. But now since these brackets are the open brackets, it means in -3 and 0 are not part of the interval. And what if we have, let's say, cross bracket, let's say -2, let's say 5, like that. As you can see, the brackets are the cross brackets. And what it means is that -2 and 5 are part of the interval. That is. And what if, let's say, if we can have, let's say 0 to 5, like that. Now in this case you can see that a part of the 0, actually a part of the 0, we have the cross interval, and in this case we have the open interval. What it means is that 0 is part of the interval, but 5 it is not. Let's say if we can have, let's say, -2, 10, like this. So now what it means is that in this case -2 is not part of the interval, but 10 is part of the interval. But all these are said to be actually the bounded intervals because they start somewhere and end somewhere with the definite number. And let's say if we can have something like this. Let's say if we have, and that should be, let's say, -2 and a positive infinity, like this. In this case, what it means is that -2 is part of the interval, but infinity is not part of interval. And always infinity has to be presented using the cross actual open intervals, because infinity does not specify the real value. It just is something that we cannot describe about It is just a very biggest number that we cannot think of. So always infinity has to be presented using actually the open brackets. And this is a typical example of, unbounded interval, because the numbers starts from -2, of which -2 is part of interval, and up to some sort of infinity, like that. And let's say if we can have a post infinity, let's say 5. So in this case, it means 5 is part of the interval, but but post infinity is not part of the interval. And the always infinity has to be presented using the open bracket. So take note of that. And also let's have to understand about the interval notation as well as the inequality notation. We understand that, let's think of having the interval that is being given as, let's say, -3, let's say -1, as it is here. As you can see, the interval starts from -3 and to -1, but all these are not part of the interval. This is what we call it as the interval notation. We call it as the interval notation. We call it as the interval notation. And how should you have to express this in inequality notation? So in this case, using the inequality notation, this is the same as, -3 and less than, x less than -1. That's what it means there. And how about, let's say, if we can have something like this. Always the starting value here has to be, the smaller value than whatever you have there. And what if, let's say, if we have for something about, what if we have, let's say, something about, there should be, let's say, 0 to, let's say, 5. Let's say that is the case. So in this case, in this interval, 0 and 5 are part of the interval. This is interval notation. But in inequality notation, we'll have it as 0, less than or equal to x, less than or equal to 5. Because 0 and 5 all are part of the interval. So we use such actually inequality symbols. And what if we have, let's say, 0 and 5 like this? So as it is here, it means 0 is not part of the interval, but 5 it is part of interval. So that is interval notation. But in inequality notation, we'll have it as 0 less than x less than or equal to 5. We'll have it as that. And that shows that 0 is not part of the interval. How about, let's say, if we have something like this? Let's say we have, 1, let's say 6. Like that. So in this case, 1 is part of interval and 6 is not part of interval. Then now in inequality notation, we'll have it as, 6 less than or equal to x less than should be 6. And that shows that 6 is not part of the interval. Like that. And let's say if we have something about, let's say, should be 5, let's say, infinity. So this is a typical unbounded interval, and it's starting from 0 up to post infinity. So in this case, that is, by the way, I should have to present that as this. It should be 5, right? Actually, it should be 5 up to the post infinity, like that. So in this case, using the inequality notation, this is the same as having it as 5 less than x, because this x specifies the numbers at infinity. So have it as 5 less than infinity, like that. So it should be 5 less than infinity, like that. And we can also have, let's say, negative, let's say, 1 post infinity. So what is this? So in this case, this is a typical an example of unbounded interval, since the values starts from -1 to post infinity. So using the inequality relation, we have it as -1 less than x, like that. And also, for the sake of interest, you can also have something like this. Let's say if we can have negative infinite, let's say 6. So in this case, what it means is that we have, what it means is that the values starts from 6 to negative infinity, of which 6 is greater than whatever the value you have towards the negative infinity. Hence, using inequality relation, we'll have it as a 6 being greater than should be x. That's what it means there, of which infinity is represented using x. So don't wonder there. What if we have, let's say, negative infinity, negative half? Let's say we have that case. Using inequality relation, we'll have it as negative half, and it means negative half is greater than x. That's how you should have it. So please take note of that. And we should also have to understand about how we can present the numbers, how we can present the intervals on the number line. So how should you have it? Let's say if we have, let's say if we can have the interval given as 5, let's say should be, let's say, 10. How should you have to present the interval on the number line? So the first thing, we have to present the number line given as this. Now this interval, it is the bounded interval. We don't need to actually show these arrows. These arrows should not appear there. You just have to indicate the horizontal line like that, and you just have to present, we have 5 here and we have 10. Now since 5 and 10 are not part of the interval, then we just have to present these brackets like that. So these brackets are showing that actually 5 and 10 are not part of the interval. Or we can present it as this. Have 5 and we have 10, and what happens is that we can have to present it as that. These open dots shows that, these unshaded dots shows that 5 and 10 are not part of the interval. So it's either you can choose presenting the interval on the number line like this, or you can have it as that. Whichever the way, the principle behind it remains the same. And how about, let's say if we have something like this. Let's say we have -2, let's say 0, sort of. Now how should you have that one? Principle remains the same. We'll have the number line, and this is a typical bounded interval. It starts from -2 and to somewhere 0, like that. And all these are part of the intervals. We'll have to present these cross brackets like that, or else you can have it as -2 and the 0, of which we'll have now the shaded dots. So have it as that. So that is another way you can choose to present the intervals rather on the number line, like that. And what if, let's say, we have something about -3, like that, let's say 2. It should be that. How should you have it on the number line? In this case, -3 is part of the interval, but 2 is not, and hence we'll have it as something about like this. So have -3 here, and we'll have some 2 here, and like that. So since 2 is not part of the interval, we can have it as open dot. You'll have the shaded dots, like that. And this is how we can have it. Or else, using the first case, we'll have it as -3, 2, and of which we'll have the cross bracket here, we'll have the open bracket. So that's the principle behind how we can present the intervals on the number line, like that. How about, let's say, if we have x greater than, let's say, 5, how should we have to present this on the number line? So what we have, it's an inequality notation, of which you should have to understand that this is the same as having it as in interval notation. This is the same as having it as should be a 5, comma, positive infinity. So like that. So on the number line, this is an unbounded interval. So have the positive infinity here, because the x values are increasing from 5 towards the positive infinity. So have 5 somewhere here, we can have that one. And since 5 is not part of the interval, you can think of having this. So this is how we can present it. Or else we can have it as, positive infinity. And have here 5, and have the open dot like that, and have it in that way. That is another way you can have it like. And how about, let's say, if we have something like this, and appreciate how we can have it. Let's say if we have, and that is, let's say, negative infinite. Let me have this. X value is less than, let's say, 10. It should be less than or equal to 10. How should you have it? So this is unbounded interval, since we have x here. Now you should have to understand that this is the same as the negative infinite and 0, because the x values are, should be, it means x values are less than or equal to 10. So it means the x values are decreasing towards the negative infinity. So in this case, we'll have that one as on the number line. Since the x values are decreasing towards the infinity, then we'll have negative infinity here. And we'll have 10 here. And 10 is part of the interval. By the way, we should have that bracket. So have it as that. So that is how we can have it. Or else you can present this. It is the same as that. So bear that in mind. And how about, let's say, if we can have for something like this, and appreciate how we can have it. Let's say we have -5 less than x less than or equal to, let's say, 5. In this case, what it means is that using the interval notation, this is the same as having it as -5 is not part of the interval. We have 5 which is part of the interval, like that. Then you present it on the number line, like that. What if we have, let's say, -pi, less than or equal to x, less than, let's say, should be a pi. How should you have it? So mind you, a pi carries the specific value that is constant, which is 22/7. So you have it like that. Then present it on the number line and see the beauty of that one. And how about, let's say, if we have -20 and less than or equal to x, less than, let's say, should be 30. How should you have it on the number line? See the beauty there. And there is something also you should have to understand. We understand that x, if x is greater than 5, this is also the same as 5 less than x. Because if we're saying x is greater than 5, it means the x values are increasing from 5 towards the positive infinity. Having this one, it is the same as having it being vice versa, in the sense that we'll have 5 being less than the x values. Because as we're saying, x values are greater than 5. It means 5 is less than the x values. That's what it means there. So in all cases, if we have x greater than a, this is the same as a less than x. If we have, let's say, x less than, let's say, a, in all cases this is the same as, should be a greater than x. So take note of that. If, let's say, we have something like, let's say if we have x greater than, let's say, 7, this is the same as 7 less than x. In all cases, that's what it means. And using the same principle, let's think of having this. If we have, let's say, 2 less than, let's say, x less than 5, let's say that is the case. Let's think of separating the case that we have here. And mind you, this x represents two conditions. This is the first condition, and this is the second condition in which this x is representing. And it is true for all cases. And are for the values between actually 2 and 5. And now, how should you have to separate this? Having the first case, or have it as 2 less than x. In the second case, or have it as x, less than 5. That's what it means. And of which this is the same as having it as x greater than 2. That's what it means. And also this is the same as 5, greater than x. That is the same as that. Understand, how we are separating that one. And let's think of having this. Let's say if we have negative 1 less than or equal to x less than or equal to 5. So what is the meaning of this? So in this case, this is the same as having negative 1 less than x, of which this is the same as x greater than or equal to negative 1. And also this is the same as x less than 5. And basically, actually, the inequality notations are well presented when we start with the variable. That is. And also, let's see how we can separate the following. Let's say if we have, should be negative 5 less than or equal to x less than or equal to, let's say, 20. This is the same as negative 5 less than x or equal to x, which is the same as x greater than or equal to negative 5. And of course, the x is less than or equal to 20, which is true. That is, of course, this is also the same as 20 greater than or equal to x. That is. And let's see how we can take it back. How should you have to combine the two bounded intervals to be actually the two unbounded intervals to be the bounded intervals? So guess how should you have it there? Now in this case, if we have, let's say, x, let me have this. If we have, let's say, x greater than 5, and let's say if we can have, and there should be something like this. If we have x greater than 5, and we should have, let's say, x is greater than, let's say, 10. Let's think of combining these two actually inequalities. So the inequality with the smaller value is given as this, so which is given as 5. So first thing, we should have to consider that one, and having it being vice versa, or have it as a 5 less than x. Then we should have, and since this one is the one having the actual larger value, this is the same as having it as greater than, and that should be 10. So that's how you should have to understand that one. And basically, let's say if we have something like, let's say, x greater than or equal to, let's say, negative 2. You have x, let's say, less than or equal to, let's say, 5. How should you have to combine the two? So the one with a smaller value is given as that one. So have it as negative 10 less than or equal to x. Then you just have to combine that one less than or equal to 5. So this is how we should have it. And how about if we can have something like this? Let's say if we have something like x greater than, let's say, 10. You have x less than, let's say, 30. how should you have to combine those? According to the principles behind, the one with the smaller value is given as 10. So have it as 10 less than x. Then just have to fix this here. So that will be given as, now we'll have it as less than or equal to 30. So that's the working principle behind. So by now you know the closed interval as well as the open interval. We understand the bounded as well as the open actual bounded intervals, how we can present the intervals on the number line, and also how we can combine the inequalities and some things there. So thank you. Don't forget to subscribe to my YouTube channel and for more updates, and also don't forget to follow on my TikTok page, and for you to be well updated on whatever the content that can be created. Thank you.